during primetime Las Vegas. Hope you're going to grab a nice drink after this, and in the meantime, we have a great talk. My name is Linda Leanne. I'm a Senior Product Marketing Manager for Serverless at AWS. And joining me today is the Vice President of Product Development at Comcast, Christopher Dixon. In this session, we're going to talk about how serverless is more than a technology decision. Serverless is the next iteration of the cloud. It enables new customer experiences and new business models, and it profoundly impacts the cost and speed with which you can bring new products and services to market. In the first half of the talk, I'll talk about the Amazon approach to accelerating innovation and how we think about serverless. In the second half of the talk, Chris is going to dive deep into how Comcast innovates and what their serverless development approach is. All right, let's get started. We're in the midst of a technology shift. Companies are increasingly global. The products and services that they build are completely digital. Customers are gaining the power of information and choice. The most successful companies are realizing that the technologies they build are critical differentiators. In fact, for many organizations, we like to say that their business is their application. 67% of business leaders believe that they must pick up the pace of digitalization to remain competitive. And it's not just about time to market, it's about the cost of delivering that value. According to Forrester, digital business leaders found that it's 10 times cheaper and faster to deliver outcomes that their customers value. 56% have said that they've seen increased profitability within just a year. And so it's no surprise that 42% of business leaders today have said that they're going to adopt a digital-first business posture. And in the fullness of time, we believe that percentage is going to be a lot closer to 100%. So how do digital innovators enable rapid innovation and do it at a lower cost? Well, to answer that question, we look deep into how we develop at Amazon, as much as we look to you, our customers, and innovative technology companies like Comcast. And we see a common set of patterns emerging. We call these new development and operational practices modern application development. And at the heart of building modern apps is the serverless approach. So next, I'm going to walk through some of the key patterns that we're seeing with building modern apps and how serverless enables each and every one of them. So the first is that we found that digital businesses become a lot more agile and flexible when they componentize their applications into loosely coupled microservices. So in contrast to monolithic applications, which you see represented on the left, microservices are modular components that interact seamlessly together to form the broader application. And the important part about each of these microservices is that they can be built, deployed, updated relatively quickly and with not much impact to the broader application. This modular enforcement allows development teams to build applications faster because independent teams within organizations are now empowered to architect, develop, deploy, and operate these services as invested owners. So an important thing about microservices is it affects a shift in mindset. So microservices eliminate the need to focus on infrastructure as a critical differentiator. And when this happens, you'll see a shift in goals. Instead of focusing on installing, configuring, and managing your compute infrastructure, you're going to start to value a standardized, flexible, and on-demand compute environment. Now, this will enable you to start focusing more time on building your application instead of managing infrastructure. And we think that's really important because we see the next wave of consumer experiences and customer experiences coming from innovations at the application layer. But just building microservices isn't enough today. We believe that the best way to take advantage of the agility that's enabled by microservices and by the cloud is with the serverless approach. We view serverless as the native architecture of the cloud. And there's 4 main tenets to every single service at AWS that we think of as being serverless. The first is that naturally, there's no servers to provision or manage or patch. The second is that these serverless services have automatic scaling. They scale by unit of work or consumption rather than by server unit. The third is that you pay for value. Now, you might be saying, what does that mean? Don't I always pay for things I value? Well, if you value things like consistent throughput or execution duration, you're paying for that unit rather than by server unit. And finally, with serverless applications, there's no need to architect for availability or fault tolerance because these things are automatically baked into the services themselves, and we manage that for you on the back end. So when you build with serverless, you can develop applications a lot faster because you're using composable building blocks that don't require infrastructure management. You write a lot less boilerplate code because these services are all interconnected either by default or through events. And finally, they're highly available and fault tolerant by nature. So diving a little bit deeper into how Amazon thinks about serverless, we don't think it's a way to package and deploy your code. We don't really think it's an architectural model. We really see it as an operational model. And that means how much operations do you want to take on versus how much you want to offload to someone like AWS. And we think it's important because the story of technology has always been about the commoditization of things like storage, networking, databases, and compute. And we're always pushing to make these things faster and cheaper for our customers. And we can do this because we have the advantage of scale. So take advantage of technology commoditization. Skate to where the value is. Think about how you can be spending time solving differentiated technology problems that have value for your business and your customers, instead of on the undifferentiated heavy lifting of infrastructure management. So let's walk through this with an example of compute. So starting at the most operations, you have virtual machines on premises. With VMs on-prem, you're managing everything from the physical infrastructure layer up. There's so many things you have to think about before you can even start to think about delivering a differentiated experience for your customers. For example, how do you secure your physical data center? How do you architect for high availability and fault tolerance? So if a part of your data center goes down, your application is still up. How do you think about managing capacity? Is your application going to be able to scale with bursty customer demand? And on the flip side of that, well, what about your utilization and cost optimization? And finally, how do you manage and cycle your server fleets so that they're always up to date and you're secure? Well, these things are really table stakes. I've never heard a customer say, wow, I really love this application because of the way they cycle their servers. That's just so deep in the stack and not something your end customers really should care about. And moving a little bit up that serverless spectrum, you probably know about EC2. Well, with EC2, we take on that physical infrastructure management. You no longer have to think about that. But you're still responsible for provisioning, managing, scaling, and patching your servers. Now let's keep going, and let's talk about ECS and EKS, or Amazon Elastic Container Service and Amazon Elastic Container Service for Kubernetes. These are our two managed container services. Well, with ECS and EKS, we provide yet another layer of abstraction for you because we're giving you a container orchestration control plane. Moving even further to the less operations side, we have something like AWS Fargate. And AWS Fargate is our serverless implementation for containers. And we call it serverless because we're managing that container orchestration control plane and we're managing the work cluster scaling on your behalf. And finally, we have AWS Lambda, which many of you probably associate with serverless. AWS Lambda is our event-driven serverless code execution service. We provide fully managed data source integrations to over 18 different event sources with more all the time. With AWS Lambda, you can use the event-driven programming model. You no longer need to worry about capacity management, and your utilization on Lambda is pretty much 100%. That's because Lambda only runs when your code runs, and the servers scale precisely to match the size of your workload. Additionally, with Lambda, high availability and fault tolerance is already built in. And now, because I keep saying serverless is an operational model, you can apply the same lens to things like databases, storage, messaging, and analytics. And it's really important that you do think about serverless across all these different things because these are the things you'll need to build a truly serverless application. And as you can see, at AWS, our mission is to bring you choice across the spectrum of how much you want to operate and how serverless you want to be. So let's take a look at how you might compose different parts of your application with those serverless Lego blocks that were on the less operation side of the spectrum. These Lego blocks, again, have the best practices of high availability, fault tolerance, elasticity, and security already baked in. The applications are oftentimes fronted by an API gateway and stitched together by events and queues. The microservices in between them are the business logic or the code that dictates the real-world interaction between your application and your end user, and those are oftentimes delivered by Lambda functions. You can use a serverless data lake and storage with Amazon S3. You can orchestrate your Lego blocks with something like AWS step functions. You can process data in real time serverlessly with Kinesis. And you can use a serverless NoSQL database with Amazon DynamoDB, or you can even choose a serverless relational database with Amazon Aurora Serverless for RDS. And as you can see, the services are only lighting up when they're called upon. And this is important. This is an abstract representation of the event-driven programming model. And this significantly improves utilization and lowers cost. So let's talk about the serverless advantage in the context of if you're an organization, you want to go from idea to experiment to production in record time. Well, in the previous world, when you built a minimum viable product or an MVP, most of these MVPs, they weren't scalable, they weren't bulletproof. And the worst part was when you moved into production, a lot of the code that you used to build the MVP would probably have to be discarded. Well, with serverless, you can build high-grade applications from the get-go. It's just much more agile. Take it from Edmonds, who found that what took us just a few days to build using a serverless solution based on AWS Lambda would have taken us 6 months to build in the past. And going back to that old world, when something scales, you kind of just had to cross your fingers and pray, hope that the capacity that you provisioned was going to work out. But with serverless, scaling is a lot more stable because elasticity is baked in. We're managing that on the back end for you at massive scale. Financial engines, for example, have found that they've experienced near zero downtime and near zero performance degradation while serving 200 to 300 million IPO requests per month. And finally, with serverless services, because you're using those Lego blocks to build your microservices, most of the code components already exist. So you need a lot less resources and a lot less time to get something up and running. And finally, with pay-per-value pricing, you can speed up development and face a lot less risk in terms of getting from MVP to production. If your experiment doesn't work out, well, you paid exactly for how much that experiment cost to run, and you can shut it down without any risks to yourself. So for example, Bustle found that the size of their team is half of what it normally needed to be to build and manage a website at their scale. And FINRA found that by using AWS Lambda, they were able to increase their cost efficiency by a factor of 2. So now that we've talked about how microservices enables agility and how serverless is a natural fit for microservices and really enhances that agility, well, there's a second part of the modern application equation, and that's how do we actually compose these decoupled services into a broader application? How do we operate them? How do we secure them at scale? And because of the distributed nature of microservices, it's really important to have a cohesive way of expressing your code and a standardized way of deploying that code. To do it manually is going to be extremely painful. And so you'll want to standardize and automate your operations by modeling infrastructure as code. You'll also want to update your applications and infrastructure quickly by automating your continuous integration and continuous deployment pipeline. You can't really automate what you can't observe, so you'll want to embrace observability to enhance application performance. And finally, once you've automated everything, you want to ensure trust by automating security and auditability. And you can do this with services like IAM, CloudTrail, and Config. These are all baked into our serverless practices. And in a couple slides, I'll talk a little bit more in detail about how you can use them. So you might have already caught on if you know development culture and practices and philosophies. What I just went through, those steps, they're actually the founding tenets of what we call DevOps, which is a combination of philosophy, practice, and tools that enable an organization's ability to deliver applications at a really, really high velocity. So if microservices enables agility, DevOps enables velocity. And really quickly about what DevOps is. So DevOps is the combination of development and operations teams that used to be separate. These teams are now no longer siloed, and an engineer owns the entire end-to-end application lifecycle. They're responsible for developing the application, testing it, putting it into production, and finally the operations of it. We found that fast companies who use the DevOps approach are 440 times faster going from code commit to deployment. That's an incredible order of magnitude increase in velocity. And when it comes to serverless, in the same way that serverless enables microservices, serverless is really at the heart of the DevOps mentality. And with serverless, you can't really incrementally adopt DevOps. It's very much baked into the DNA of how to develop a serverless application. Serverless enables operability from the start. Let's take the example of AWS Lambda. With Lambda, you have to think about how a code will be run at the time that you're developing your code. So you have to specify the memory and the execution time, or how long your code is going to run. And after that, when your function gets invoked, those two settings influence the price of running your Lambda function. So as a Lambda developer, you don't have the luxury of developing your code in isolation, then throwing it over the wall to an operations team, just assuming that they'll be able to make it run for you. You really have to think about how it'll run at the beginning. Security is another great example of software delivery where it's often addressed as an afterthought, or it's the purview of a delegated security team who have to assess and sign off on software components before they can be put into production. And as you can see, this isn't really the best enabler of agility and velocity. So when a DevOps team also thinks about security during the development process, we call that DevSecOps. And with serverless, once again, security has to be considered as soon as the function is written, during the normal course of development activities. So for example, at a minimum, you need to set the permissions for what individual Lambda functions can do and the resource or events that can trigger it. Each function is independently secured and auditable with AWS CloudTrail and authenticated and authorized with AWS IAM. With Lambda, you can bring the full power of security to every single interaction, even internal system-to-system calls. This really protects against evolution and accidents over time. And think about this as juxtaposed against the monolithic model where you're really using perimeter-based security. And just because microservices have more surface volume and surface area doesn't mean that it has to be more difficult or more complicated to manage. A service like AWS Config lets you enforce the same policy across a group of Lambda functions, ensuring that you're able to have granularity and control, even with a microservices-based architecture. So thinking about security from the start enables organizations to build production-ready applications from the get-go. And you're wasting a lot less time when you have to take that MVP into production. So to quickly recap, the journey we just went through is precisely how Amazon accelerates innovation. First, we enable agility by architecting our applications as microservices. And then we offload as much operational overhead as possible by building these microservices with serverless Lego blocks. Doing this allows us to focus on solving technology problems that have differentiated value for our businesses and our customers, instead of on undifferentiated heavy lifting. Finally, using serverless also compels us to use DevOps best practices, like expressing infrastructure as code and automating our security and monitoring. To sustain the changes in development practices, you also need to think about something that's a little bit less tangible and something that Chris is going to dive deep into, and that's around culture. We create a culture of innovation by organizing into very small DevOps teams, or what we at Amazon call 2 pizza teams. We call them 2 pizza teams, there you go, 2 pizzas, because 2 pizzas is exactly the size that can, 2 pizzas is the right amount of food that can feed a team of that size. And so if you use serverless, you probably won't need a team much larger than this. There's another thing I want to highlight about culture, and that's an interesting concept called Conway's Law. It states that any organization that designs a system will inevitably produce a design whose structure is a copy of the organization's communication structure. So think about how small, autonomous development teams can best serve your serverless and microservices-based approach. So you might be thinking, wow, this sounds awesome. I want to realize the elasticity, scalability, cost efficiency, agility, security benefits of serverless. I want to start developing my next project in serverless tomorrow. Well, if you're part of a large organization, it's not always as easy as it seems. There are some blockers for innovation. So as we talked about, you need to start organizing into small development teams. So that's culture, and something that Chris is, again, going to talk a lot about. There's also organization. Hiring, retention, and training are all really, really important as well. But there's a final important blocker that isn't as obvious, and that's finance. And I'm going to talk about it more broadly, and Chris is going to dive a lot deeper into how he approaches finance and serverless development at Comcast. So with finance, there's a really interesting metric, and it's something that shareholders, investors, and organizations alike use to measure their profitability, and that's EBITDA, or earnings before interest, taxes, depreciation, and amortization. Now, for the purposes of our story, I really want to focus on the E and the D, or the earnings before depreciation. And the reason why it matters is because organizations who invest on premises and have server hardware costs, well, they depreciate these costs as capital expenditure. Excuse me. In the same way that you might purchase a car and the value of that car depreciates over time, an organization will depreciate their server hardware costs over time. And that goes into depreciation. And why that matters is because EBITDA, or earnings before depreciation, does not take into account this depreciation cost. So as a result, most of the time, server hardware costs are centrally managed. It's really hard for a finance team to even be able to tell you how much of those centrally managed costs can be allocated to your individual project. And that causes problems for us in a serverless world, because when you switch to serverless, it's pay as you go, and those prices and the costs, they go onto your P&L as operating expenditure, or what we call OpEx. And so suddenly, you are bearing the costs of developing that application directly within your business unit. So for your next project, if you want to go serverless, you probably have to do some convincing with your finance team, even though the actual costs of developing that application on an allocated basis are probably less. We actually think there's really exciting and novel new implications for finance in a serverless first world. For example, the fine-grained serverless billing model will allow you to know precisely how much your application costs to run. It'll actually let you know exactly how much each microservice or nanoservice or even function costs to run within your application. This type of visibility and granularity is going to enable new pricing models. So everybody visualize your favorite SaaS application, something you use every single day. It could be Salesforce, it could be Tableau, what have you. Well, imagine paying for usage rather than by seat or per license. That's the kind of pricing model that a serverless world will enable. And again, Chris is going to be diving a lot deeper into this. So I'll leave everyone with a parting thought. Our CEO, Andy Jassy, recently said in a Forbes article that if Amazon.com were being created today, it would go serverless. So my ask to you is think about how serverless can help accelerate innovation at your organization. Thank you, and with that, please give Chris a warm welcome to the stage.
All right, thank you very much. So my name's Chris Dixon. I'm the Vice President of Product Development at Comcast, and I'm in charge of our Digital First DevOps team. For us, Digital First includes our identity management organization, our self-service My Account services, including help and support, our e-commerce tools for our customers and our agents, as well as messaging applications, email and SMS. Now, these types of rooms, we tend to have some Comcast customers in the audience, so I want to thank you for being a Comcast customer, and hopefully some of the things you're going to hear about today will resonate with you as things you either recognize that we're doing or hope that we're doing in the back office to advance some of the interests of both you and us. But for those people who are in the room that aren't Comcast customers, or many people who actually might be from out of town, we've composed a little bit of a video clip that explains something about the company.
I think I found my team.
This should be interesting. Our story is just getting started.
I'm so happy to be here on SNL.
Show me. Your Wi-Fi is a fiber connection with gigabit speed. It's good. This is our home. Nothing scary here.
What's going on? What's happening?
That was amazing.
There's a lot to try and understand here and much to learn.
I got goosebumps.
My hand's gonna reach down and hit that button.
We got business here.
Breaking news to bring you right here on CNBC.
Every time we've unveiled a new attraction, attendance has spiked.
I want more.
Let's give her a round of applause. Vote for the voice.
This is gonna be awesome.
Now, what did we learn in that video? It's not a sales pitch for Comcast and NBC Universal, although I happen to be a fanboy of many of the technologies and assets that you just saw. It's more of a reminder that Comcast was founded in 1963 in Tupelo, Mississippi as a small cable company. And we've come a very long way in terms of technology and growth of the company. Amazon was founded in 1994 as an online bookseller. And as you can imagine, we are, as a cable company, continue to provide cable services, and Amazon still sells a lot of books. But both companies have acknowledged that the technology and the teams that we've put together are critical in how we continue to evolve our companies to be what Brian Roberts calls fiercely competitive. Some behind the scenes about where Comcast is innovative and drives technology. These are our distribution of some of our development shops around the United States and around the world. In Washington, D.C., for example, we have voice control and the voice remote team. If you're X1 subscribers, you probably are familiar with this. San Francisco and the Silicon Valley area, we're dealing with Internet of Things and set-top box applications. In Denver, a lot of our big data capabilities and our IP video streaming networks and player technologies, and we're headquartered in Philadelphia, where a lot of our product development is also centered. All of this is actually enabled by serverless. The common approaches and technology stacks that are used by each one of these development teams enables for each development team to get together and compose microservices that, when coordinated, can result in a meaningful product to our customers and our employees. We also bring in innovation and teams from the outside. We have investments in key strategic partners. Comcast Ventures provides investments in companies that are growing faster and ways where we can interoperate with them. We accelerate through partnership with Lyft Labs, and then we acquire and partner with other companies. So why am I here? So in January 2018, Comcast announced that Amazon is Comcast's preferred cloud provider. But well before that, in 2006, my teams were the first ones to launch EC2, publicly facing for a social networking application that we were working on at the time. It was brand new, and it was a bit of a risk for us. And how do I know we were the first? Because in 2007 or 8, a couple years after we did that, the finance team came into my office and knocked on the door and said, "Why is your P card operating all of these Amazon instances that all these people are standing up?" I said, "Could I put my Miles card instead on it, maybe?" So what we've done, though, since that point, we've continued to replace our own internally managed solutions for the exact same reasons that Linda was mentioning. We've replaced queuing systems with Amazon SQS, pub-sub systems that we were running inside of our own operations centers with Amazon SNS. We replaced Oracle and SQL Server with Aurora DB, Couchbase with Dynamo, Splunk and Hadoop with Redshift. And many of these are hybrid solutions. We'll talk a little bit about that later. They're not native inside the Amazon environment with no access into the Comcast network. And that's an important distinction. You can begin to insert serverless capabilities within your own framework without deciding to go all in on Amazon. And every day we find new ways to use serverless to approach hard problems, sometimes previously impossible problems, and solve them with new technologies and approaches. And that's why this partnership with Amazon is so important. So as Linda mentioned, we're going to be talking about three elements of the puzzle that I consider critical to success for serverless. Technology is the one that people talk a lot about. There's great technology sessions in this entire convention. But there's two pieces of the puzzle that are often not discussed, which are really important. The value equation and also the organization or culture, as Linda called it. So we're going to spend a little bit of time talking about each of these three pieces. But as we are a Philadelphia headquartered company, I thought it would be important for us to bring in one of the most famous Philadelphia entrepreneurs to help us in this journey and provide us a little bit of guidance on how serverless is approached. Mr. Benjamin Franklin. First American founding father, and the look on his face says, I'm missing a pub crawl for this event. But he was an inventor. He was a doer, as are you all, and that's why you're here. So Benjamin Franklin would be here with you, I imagine. So it's amazing how much he would have to say about serverless if he were alive today. So we're going to channel some of the quotes that you probably are familiar with into an analysis about what that would mean inside the serverless landscape. The first one as we begin our technology journey is, well done is better than well said. So how much value is a great idea to your company if it never sees the light of day, for whatever reason, whether you didn't have the right team or the right technology or the right financial model to make it successful? Serverless reduces the friction to take a great idea and launch it into production. It eliminates the VM provisioning, OS configurations, sizing, or even auto-scaling. It allows you to reduce or eliminate the long tail of maintenance and software patching. It allows your team of developers to do what it is you hired them to do. It allows them to be creative and launch great products to satisfy your customers and your employees' needs. So we have a lot of examples of serverless, and there's too many to go through today. So I picked three that are at size and scale, pretty interesting to talk about. But before we talk about it, we want to talk about some of the filters that Comcast puts on top of some of the value propositions that Linda mentioned about serverless. First off, we talked a lot about scale. And serverless clearly provides the scale that we need to grow, with a few exceptions that we'll talk about in the next slide. Your CI/CD integration, pipeline, and support for a variety of languages can help overhaul and create a different type of team than what you have today. Virtual private clouds, for us, is critical, as a lot of the Comcast services that we're calling are in our own network, and Amazon's serverless components need to feel to those back-office services at Comcast like they are also on their own network. Amazon Web Service modules and serverless components play very nicely with each other. If you begin with SQS, it's very easy to add on SNS, Lambda, S3, Redshift as time goes by. My favorite non-technical thing that serverless gets us is a little bit about what Linda talked about, the ability to tag components within serverless against a particular team or particular program to make it more easy for you to track back the value equation that becomes critical in the second part of this presentation. Some other considerations, though, that you need to at least have in mind when you're approaching serverless. There may be things in your company that you do better than anybody else. There may be certain pieces of the puzzle that Amazon has put together that are not necessarily your strategic value proposition, and you need something more that only your teams can provide. If you're developing in unique languages that perhaps Lambda and other serverless components may not support, then you need to consider that going in as well. For example, COBOL, Fortran, maybe. If you're still using COBOL and Fortran, this may be the wrong session for you. You need to understand and how to deal with the proper set of configurations and components and sizing requirements that go into serverless. Linda mentioned a little bit about the duration and memory requirements for Lambda, but there's also concurrent read limits and sizing considerations you have to consider to get the value equation right and to make sure your performance is where you need it to be. And finally, migration of code, and especially data, is something that you need focus and organizational buy-in before you can even attempt. So we're going to go into the 3 examples, and we're going to begin with 2 in the identity space. Anupra Davis, our Chief Security Officer, will guide us through this process and emphasize that there's a lot of stuff that goes on behind the scenes to protect our systems and our customer information. And before I go into that a little bit, I want to talk about the first serverless implementation we did at scale that was behind the scenes. In 2013, we decided to make an investment. In addition to the logging features we already had inside our components, we added in Kinesis and Firehose and Redshift. And we established a parallel logging track with all of the things we were already depositing in our current logging mechanism with these 3 pieces of technology with basically 2 goals. One is real-time access to the events as they were occurring. And the second was long-term persistence of that data so we can watch for seasonal or even annual trends. These are things that we could not do before those 3 particular pieces of serverless that we've grown fond of were announced. So every day, security gets more challenging for companies like Comcast and probably many of you in this room. And it's tremendously important that we continue to innovate in those areas. And those investments in 2013 laid the foundation for the next 2 examples that we're going to discuss. And also note, I think I've got an asterisk next to Elastic Beanstalk. Linda did mention serverless is all about not knowing the sizes of your servers, not caring about the size of your servers. And Beanstalk is not quite serverless in that way. But bear with me, we'll talk about why Beanstalk is part of our equation. So let's talk about bad guys on their first example. Does anybody know what happened in 2016, a tipping point in terms of bot traffic? It was the first time bot traffic exceeded human being traffic on the internet. Some of these bots are friendly bots. These are bots that are helping to make your search results more interesting or allow us to smoke test and QA already deployed code. Some of these bots, though, are malicious, and they have bad intentions on our sites and probably your own. And it's critical, as I'm sure you would agree, to watch closely for the malicious bots, try to isolate them and identify them, and then cut them off before they can cause damage. So using Kinesis, Lambda, and Redshift, we began looking at the inbound traffic across all of our authentication methods, and we were looking for specific things. In many cases, invalid authentication attempts gives us a chance to isolate what might be a bot. If we see enough of them in a certain period of time, we will be able to blacklist the IP address or the username that's being used for the attack. And then we can interrupt the traffic in a variety of ways. The easiest one, and the one that's most depicted here, is CAPTCHA, that enter these characters or I am not a robot. In this case, we actually had an IP address that came at us, and it attacked us with 3,000 requests over a certain period of time for the same username and the same password, trying to guess the password. We identified it using real-time data analytics that was available to us in serverless, and we're able to pop CAPTCHA, and you see the result. It shut down the traffic immediately. The factors here on the left-hand side are a mix of the foundational technologies that we put in place with serverless, as well as the implementation of this malicious bot defense mechanism. 22 billion rows of data with 15 months of queryable data. 4 terabytes of data is stored in this Redshift repository that allows us to do some of these activities. For the particular bot capability, 50,000 queries per day and sub-second response times gives us an edge on some of the malicious bots as we see them. But bad guys aren't the only thing we have to look out for. We also have to look out for the good guys. As you can imagine, from an authentication perspective, Comcast has a number of properties that rely on our logging or our login infrastructure, usernames and passwords and 2-factor authentication challenges. Each one of these clients is listed on this slide. This is not a stacked slide, and the y-axis, which is hard to see, are millions of transactions. If any one of these particular clients were to introduce a bug in their code, it could negatively impact all of the other clients involved. And we were seeing that over and over again. And so we took one of the more expensive and critical features of our authentication infrastructure, that of OAuth token analysis and providing back client information from a customer information into the client infrastructure for each one of these transactions, and put it into Elastic Beanstalk. And you could see what happened when we had one of our major clients for authentication quadruple its traffic by introducing a retry logic bug. We were able to withstand the traffic with only 3 micro servers, east and west. And we can't get into cost specifically, but you probably paid more for breakfast this morning than it cost for us to run this for the month. So why do we use Beanstalk? It's important to point out, Linda mentioned that the duration computes for Lambda are critical, but the duration computes for Lambda are 100 millisecond is the least. And you can see the performance that we have in these systems are sub 2 millisecond response times. So Elastic Beanstalk was the better way, the more efficient way to provide the same service. So finally, as our technology examples, enter Netflix. In 2016, Comcast and Netflix established a partnership where the capabilities that we were providing to Netflix as an application provider inside our set-top boxes it was our search capabilities, our voice remote capabilities, and our ability to play Netflix content if you're already a Netflix subscriber. Now, the problem with any sort of set-top box related solution is the scale. I think many of you in this audience probably think about prime time as sort of the shorthand of your peak moments in the day or in the week where you see the most traffic on your systems. Well, we literally have prime time. 8 p.m. Eastern through 10 p.m. Pacific, we see spikes every hour and every half hour from tens of millions of devices, people picking up remotes and deciding to change a channel, DVRs beginning to fire off, and maybe people launching Netflix. Additionally, this particular business development requirement came along with a very strict timeline, 4 months. And by the way, we had many dev teams with full backlogs, and we didn't have enough capacity to tackle Netflix in the way that we would like without serverless. So this isn't a tech talk, but we will go through a little bit of the architecture. First off, we use Akamai for our traffic shaping inside of our Netflix experience, and this is a connectivity between the set-top box and the Comcast back office. We use Amazon API Gateway to front that traffic, and Comcast has a variety of security mechanisms that we've already developed that are critical to securing the traffic on the inside of our networks, and so we've created a custom Lambda authorizer. The Lambda capabilities to provide the functionality necessary for the set-top boxes are then kicked off, and we use Kinesis for data streams, DynamoDB for lookups, Secrets Manager to protect all of the traffic, and then SNS to provide eventing logic for other people who are interested in these critical features that are going on. Redshift and S3 are used for logging and data persistence, and we use Bodo as our framework for creating this application. All of this connects to the Comcast on-premise capabilities using the virtual private cloud that we discussed. That allows for the Comcast services and the Amazon services to cohabitate in a way that could accomplish this critical feature for our Netflix and our set-top box partners. So this is our largest customer-facing serverless component to date. 512 megs of RAM is allocated for a number of Python functions that were written. We have 160 million transactions per month. And the peak times in the P95s are around 1.2 seconds, and that's mostly from the Comcast back office side of things. It is not the Amazon serverless latencies that are critical to us. 4 months, though, 2 developers. I mentioned our DevOps teams were otherwise occupied, and so we were able to only pull away 2 developers to work on this, and we gave them 4 months to do the job. And Linda insists that I take a little bit of humble pie and admit that I was one of the developers. So if I can do it, you can do it. And I'm glad that we didn't have the 2 pizza thing going on, because I would be very fat. Right now, we'd have 2 very fat developers. But in the end, what we found was something that we didn't really have a choice. A lot of you may have choices about when to migrate and how to migrate into serverless, and how to begin sort of getting closer to where you want to be in a serverless perspective in the long run. We had 4 months, and we had no choice. We could not have done it with our team, the way it was sized. We could not have done it with our systems, the way they were deployed. So this concludes our technology talk. Let's talk about value. Mr. Franklin, with the same look on his face, reminds us that a penny saved is a penny earned. Linda already explained CapEx and OpEx are actually the critical piece here. Comcast has invested a lot of capital in building our own virtual machines, platforms as a service, logging mechanisms, management consoles, and they are all available to me as a Comcast development manager for free. Free to me, at least. So with the excitement and the direction of going into serverless, what do you think happens when I walk into the Comcast Cloud office and knock on the door and say, hey, good news. I just shut down 1,000 VMs in the Comcast Cloud. And I did it with like 3 Redshift and Lambda functions deployed in this way, and I slid the architecture across the table, and they said, that's great, thank you for that. Wonderful job. Now we're going to take that capacity you just released, and we're going to give it over to somebody else. I said, well, that's great, but I need to pay Amazon, right? And they're like, not with our money. So a penny saved is a penny earned, yes, but it's not my penny. So how do we do all of the things that we've been telling you about? These stories are real, but they're funded. But they've been funded from our development organization as a way to invest in things that were meaningful and even impossible without using serverless. So that means that since it's my money and my team's money, we have to be very, very careful about how we spend that money. The next slide is going to talk about a year in the life. And I have a bit of a reputation at Comcast of being an advocate of Amazon solutions. And I often come into teams that aren't using serverless, and I encourage them to get into a mode where they're migrating technologies out of our existing VM architecture and into serverless for all of the reasons why Linda and I have been talking about serverless as being a powerful tool for you. So as a reformed developer, I should have started this slide at 0, because that's how you begin to count as developers. The 0 event here is going to the dev team and saying, hey, let's migrate. And they'll say, why? They'll say, performance, scale, DevOps, pizzas, whatever, let's migrate, let's do it. I left out something critical, the value equation. And that was my mistake, and you'll see the trap in a minute. So step 1 is probably something you all have experienced. When you have your admins and your security mechanisms and your access controls in place, you begin to put traffic inside of your Amazon environment. Step 2, the traffic begins ramping up. You get a rhythm about it. You begin deploying services inside serverless that are doing great things for your company. Between step 2 and step 3, a decision is made to migrate a certain set of services out of your own cloud and put it into Amazon. Just shy of step 3, I get a knock on my office. Business operations person is there. He says, if you keep this up, you will be totally out of money in 2 more months. I said, why? He said, look at the Amazon bill. I'm like, what's this all about? He said, I don't know. That's the Amazon bill. So in step 3, we went to the developers and the development leads that were working on the migration. And we started to talk with them about what was really going on. And they weren't looking at the costs. And that's okay, because remember, up until this point, any internal Comcast capabilities is essentially free. They didn't have to look at the cost before. So we got a team of people who had already implemented serverless, understood how to configure, understood how to size, and got them into a room of the people who were just learning how to do it and said, help us. Here's the value equation part that I forgot to tell you in the zero event here. What can we do? Well, they formed their own 2-pizza team, although we're a Philly company, so it was probably cheesesteaks, and I don't know what the exchange rate between pizzas and cheesesteaks are, but it was about a 5 or 6 person team, and they began looking hard at the costs. And they began looking at the dashboards that Amazon provides that allows you to tag those serverless capabilities and assign them to a project team. There's a whole Slack channel of people just saying, what's this serverless component called whatever? Who owns it? Please tag it correctly. So they could begin then talking to those development teams about the size and about the capabilities that they were trying to deploy and ensure it's sized and deployed correctly. And you saw what happened. Between 3 and 4, we began to optimize our serverless deployment. And in step 4, we found sort of the complete optimal way, because there's another traffic line here that's not shown. We are continuing to add services and traffic and other things onto our serverless environment. In step 4, you see a tight little lift, though. That was a deployment of a secrets manager code that was not written in an optimal fashion. But by this time, the team that was in charge of the governance of our Amazon environment saw it before our very nervous business operations person saw it and already had it in hand by the time he knocked on the door. Double-clicking on this a little bit, you could see the migrated service was our Elasticsearch service came out of the Comcast cloud. And you could see in the purple, that's last year in October's cost. And in the orange, it's July of this year. And the difference is striking. When we deployed Elasticsearch from Comcast, where it was free to me, into Amazon, where they knew exactly where to send the bill, it was more than all of our Amazon services combined. And you can see it wasn't completely eliminated with this team. They just found the right implementation of Elasticsearch inside Amazon and migrated the ones that weren't necessary to be within Amazon back. Our Databases were correctly sized from an Aurora perspective, just going down the list. And the bottom parts of the list are the ones that are interesting. They went up. But those are the native capabilities within Amazon. That's Lambda, Redshift, API Gateway. Those are the per-use charged instances. And that's the kind of graph you'd like to have inside your own operation. So if cost isn't the thing that you can rely upon exclusively for serverless, what else? If you can't extract company value from CapEx to OpEx and exchange that money, what else is there? What about time to market? The Netflix application couldn't have been done without using serverless within our own networks. So how do you work with your finance team to help them understand how to calculate the full cost of running things inside of your own environment and how much advantage serverless can have? You might not solve your 2019 budget problem, but you might begin to lay the groundwork for 2020 and years to come. Between now and then, if you're investing your own dollars from your own DevOps organization, you need to make sure you're using the Amazon Web Services capabilities efficiently. And is there something else that's driving it? Is there something maybe less substantial, but maybe more important than any of this? Let's first summarize the value equation, and we'll get into the answer to that question. Since it is not about a penny saved is a penny earned, I look to Benjamin Franklin again, and he reminds us that an investment in knowledge pays the best interest. And this knowledge investment is not only for your customers, but it's also for your employees and the teams within your company. And that's where we're going to begin the third and final part of this organization, part of this presentation, is organization. So tell me and I forget, teach me and I may remember, and involve me and I learn. You've already seen evidence of this in the value discussion when a governance team was given the right KPIs and the right exposure to what was important, what they did. These are the most critical pieces of your organization, the engineers. They are smart. They want to do great things. You just have to explain to them clearly and efficiently what it is you want them to do. But there are other things you might want to put in place to encourage the behavior patterns you're looking for. Some of the traditional measurements for success within your companies and even within Comcast include site traffic, revenue, and performance of your applications. But at what cost? What sort of teams do you have? How long does it take for the team that you have to deploy the features that you need? And how often do you review those features to determine whether they still are adding value to your customer? If you look at your DevOps pipeline, are you asking them to focus on automation or observability? Which is what Linda was mentioning before. Monitoring. How often are you looking at your own data to make informed decisions? Do you and your team, if you're thinking about not going to serverless because you already have deployed components, do you really know what's going on inside those monolithic pieces of software that have been with you for several years? So also, when you look at the costs, what costs do you look at? Team costs and software licensing are easy. But again, if you are able to isolate on a cost per activity and encourage the team to look at the cost per activity, it's much easier to begin talking about what serverless brings to you. In the e-commerce world, we may look at cost per order. When you click the button, does it place the order without anybody else getting involved? That's one of our critical measurements. We can count the number of orders, but the cost per order is much more complicated, especially if you're trying to lay the groundwork for a discussion with your finance team, and you say, how much is the cost per order? And they say, well, how big is the team, and how much software licensing are we charging? We say, well, yeah, that's fine, I've got that. But I'd like to include some analysis on how many servers we're running inside of our own network to provide this, and how much those servers cost the company, because I'm considering another capability like serverless that allows us to reduce that. By having those conversations with your team in the open, in the clear, you'll begin to get their cooperation, and even the finance team in the next couple years will probably come around to what it is you're trying to do. So what else is important? These are your A players. These are your most intelligent members of your development organization or your engineers, and you need to invest in them. They want personal and professional growth. They want hard problems to solve, maybe even impossible problems to solve, because those are the most rewarding and interesting. They want the ability to learn and apply new methods to these hard problems. And they want to be able to tell stories. These stories are really important within your organizations. Looking around, are your stories about governance, or are your stories about performance? Do you talk about roadmaps, the next 1 to 3 years worth of features that you're going to be deploying to your customers? Or do you talk about releases, the next 1 to 3 months worth of activity that your team needs to do to be successful? Do you talk about customer features, the things you think your customers are going to want when you finally get it out the door? Or do you talk about getting customer feedback as soon as possible by launching into production as quickly as you can? Do you talk about pilots or trials and say, I want to reduce risk by doing something small? Or do you increase the risk and the reward by going into production quickly? The picture on the right is actually one of my favorite pictures in all of my Comcast career. This is a 2012 picture of our launch for the Xbox 360 application of the Xfinity video solution. Now, it's probably a lot more than 2 pizzas, but there's a lot of Twizzlers and other things on the table. But the point is, when I talk to other people who were in that room or knew about that room, that's the story that they cherished the most. We were able to do something like Netflix in a very short period of time with a very small team. And Amazon provided us some solutions there with EC2, but it's 2012. It's well before Lambda and other serverless capabilities that we would probably be using today, to echo what Linda mentioned about Andy Jassy's desire to use serverless to consider what Amazon would look like. Same thing could go for any one of these solutions, and probably your own. So you need to evolve. This is the final quote from Mr. Franklin. And he reminds us that all teams are divided into 3 classes: those that are immovable, those that are movable, and those that move. Serverless allows the teams that move the power to provide great solutions for your own companies. And that's actually our final quote for the night. Is from Charlie Heron, our Chief Customer Experience Officer, and he reminds us that it is our jobs to reduce the friction from a great idea to a deployed feature that our customers and our employees are able to consume and enjoy. I hope the stories that I've provided for you today gives you some pieces of analysis you can take back to your own teams and begin thinking about your problems in your own way. I thank you very much for your time, and on behalf of Linda, please enjoy the show. And also, please complete the session analysis and survey in the mobile app. Thank you very much.